I'm going to go over calibration of angle beam, contact, ultrasonic testing using an IIW Type 2 block. The equipment I have is the Epic 1000i from Olympus, and I'm using an AWS wedge, which is 45 degrees. This is a typical AWS wedge, and I'm using a 2.25 megahertz transducer. The Type 2 IIW block has a 2 and a 4 inch radius, 2 inch radius and the 4 inch radius. So those are the two reflectors that we will use for calibration. Remember always to couple your transducer to your wedge, otherwise you won't get any energy. So to start with, I set my machine at 5 inches, the range, because I'm using a 2 and a 4 inch radius. I want to set my range at 5 inches, that way I'll be able to capture both those reflectors, the 2 and 4 inch. My velocity is 0.128 inches per microsecond, which is your typical shear wave of mild carbon steel. The zero I set to 0 because the calibration will take into account the time lost in the wedge, so it will 0. Pulsar, make sure you always set your machine to match transducer, 2.25 megahertz. Of course, with the Olympus machine, it does not have a 2.25 megahertz setting, as a 2.27 megahertz. So use that. It's slightly above 2.25. So I'm going to put some coupling on my transducer, or excuse me, on my IIW block, and right here is a 0 marking. That is the machine mark on the IIW Type 2 block. From this point to this radius is 4 inches, and then on the other side was that 2 inch radius. So I'm going to couple my transducer to the block, and I see 2 reflectors. Now the Olympus Epic 1000i has a peak memory. What I'm going to do is just move back and forth, and you can see the trace is remembered there, how it shows that trace. I'm going to peak right in the center of that curve. What that is my beam index point. That is where the maximum energy is coming back from this radius. And again, I'm using a 45 degree angle. And by the way, in our trig functions, I set my angle to 45 degrees because that's what the wedge that I'm using. So I found the peak where that signal is the strongest, and what I did, I have a piece of tape here. I marked, that's my beam index point, that 0 machine mark on the IIW block. I marked on this masking tape where that point is. That's my beam index point. So now I want to calibrate. We have this transducer in a position where I'm getting my maximum energy back. I want to take my gate, move it over that first reflector, and that's the 2 inch radius. I'm going to take it to 80% full screen height. This tester has the ability to do second function auto 80, and it'll take that signal to 80% full screen height. I want to push my AutoCal button, and AutoCal comes up, calibration mode, sound path. There's a cal velocity and a cal 0. That 2 inch radius that's coming, reflecting back, I want to press cal 0 to calibrate the 0 of my machine, and the machine comes back and wants to know what that value is. So I'm going to change that value to say that that sound path is 2 inches. There, 2 inches. Press the check to continue. So I stored that value. Now let me take my gate, move it over to my 4-inch radius, which is this reflector right here, 4-inch sound path. Again, second auto 80. I want to bring it down to 80% full screen height. Then I'm going to press my velocity. We've called our 0. Now let's cal the velocity. Press cal velocity, and again the machine is asking you what is that value, that sound path, and it's 4 inches. So I'll adjust this to 4 inches, and then the check mark will calculate, and that will calculate my calibration and completes the calibration. In this case, the 0 is 14.12 microseconds. That's how much time is spent in the wedge. It doesn't take into account the steel. We don't want to have the wasted time into our calculation. And velocity for this IIW reference block, it changed the velocity from 0.128 to 0.129 inches per microsecond. And we can double check. I can bring the gate over by 4-inch radius and look at my sound path up here, 4 inches. Bring the gate over to my 2-inch radius and take that to 80% full screen height, and it's right at 2 inches. So now our machine is calibrated. The next thing we want to do is we want to see, is this wedge really 45 degrees? Under use, it could change the angle slightly, so we always want to measure our real angle. And the way we do that, on this IIW Type 2 block, I have a scale here. In this case, I'm using a 45 degree transducer. I have a scale that is from 30 degrees to 60 degrees along here. And what that does is this sound, I'm shooting down at this hole here. I'm looking for my maximum sound to come back. And let me couple this. And here's the 45 degree mark. So I should be right in the ballpark here. So I'm going to couple it up. And let me take a little bit of gain out of this guy because I'm off the screen. And still off the screen. Take a little bit more gain out. Goodness gracious. Here we go. A little bit more. Now let me hit the peak memory, and I'm going to see where that signal peaks. That signal peaks right there, and I am measuring 43 degrees. This wedge, and using this hole, is coming back, and I look at my beam index point I have marked, and looking at the scale, it says 45, 44, 43 degrees. So, it's slightly off. What I want to do is go into my trig function. I want to change my angle from 45 degrees to 43 degrees. And that was a... And this is in, when it's underlined, angle is coarse. When you press the check button, it'll put it in the fine mode, and 43 degrees. And there we go. There's 43 degrees. So I'm telling the machine that I'm actually using a 43 degree wedge, and by putting it in your trig function, it will keep all your calculations correct. So now we've calibrated, we've measured our angle. The last thing I want to show you is to set your reference sensitivity. And the IIW block has a 60 thousandths through hole that is 0.6 inches deep. So I want to change my range. 45 degrees, only need about a 2-inch range to find this hole, just to make use of our screen width. Alright, change my range to 2 inches. There it is. I couple this guy up and I'm going to use my 45 degree to find this side drilled hole. I see it popping up right about here. Let me take that to auto 80. And let's zero that again. I'll find the peak energy. And right about there. Look like that's the peak. So that is 45 degrees shooting down to that 0.6 inch deep hole. That is used for my reference. Now, with AWS, I believe it says the code says to set your reference level between 40 and 60% full screen height. So I'm going to change my gain and bring this guy down to right about there. That's 60% right here. 60% full screen height. That is your typical reference level for AWS exam. And of course, depending on the thickness of your part, you'd have to look at the code. You always scan hot. This is your reference dB. In this case, it's 55.6 dB. Typically, you'll run 6 dB to 12 dB hot. Depends on the code. But this is your reference level and what you would evaluate indications at this reference level.